Hey, thanks for enduring for the last day of the reInvent and almost the last session of the last day. And all 27 of you, thank you for being here. We'll have fun time. But by the way, this is the enterprise track. It will not go as deeply technical as maybe you expect. Definitely we'll talk a lot about the process, a lot about the people, and a lot about how to engage and approach the large-scale enterprise application migration, particularly when you're looking into really vast portfolios. So I'm talking about not 1 or 2 or 5 apps. I'm talking about 100, 500, 5,000 apps. My name is Miha, and I mean, if you don't like my East European accent, probably right now would be a good time that you find a better session. Paul, that would actually translate from my horrible East European idioms back into American, lost his voice last night, and we are not going to ask him over there what exactly he did for. But I hope that you had at least as good time as he did to, to do all of that. After my initial 20, 25, 30 minutes talking how we think that we should do our migrations to our cloud, which is kind of very self-centric, I definitely want to give much more relevant voice to our customer from Expedia. So we'll ask Aman and Magesh to come on the stage, and they will actually give you the first-person impression of application migration they did in Expedia and actually how they created a migration factory and how fast can they move and migrate applications over. So with that, let me actually start with a couple of objectives. What I hope that you will get out from here, or at least that you will remember next week, thinking back about why on earth was I in that room on Friday morning. The first one is that when you're looking into the application portfolio migration, it's actually a very complex set of the journey. If you were not in any of my other sessions before in a week, actually, this is almost like a session number 3 of a series, right? Probably the cover type of a session was last afternoon, talking about a complete framework of journey to the cloud that large enterprises need to do, where definitely application portfolio migration is a very big component of it, but just a component. And the other session that Paul and I were doing while Paul still had a voice was about the hybrid integration and hybrid infrastructure, which is the necessary required component. It's like a prerequisite before you can actually kick off the application migration going through. So here I'm assuming first that you have a larger order of the governance program in place, and I will assume that there is a target already, that the platform and connectivity and the identity and the security envelope and all of those base components to actually have that hybrid integration with the VPC on the other side exists. So now we are looking in that pile of stuff in the environment and the executive direction to move them over. And the session is mostly about how you first go and look into the pile and what are the possible options to actually kick off the migration factory. A little bit about the operational migration, but actually I will rather show you much more about how do we structure architecturally, people-wise, process-wise, those things. And put the shameless plug into our cloud adoption framework that we just launched yesterday, and then we'll actually look into the practical case study. So let's go straight into the meat of the session, which is starting with a current state. Our big issue is how to properly approach the application portfolio assessment when we work on very large engagements. Probably I need to tell you first where we are coming from, or I'm coming from, because Paul and I, we both work in Amazon Web Services Professional Services. So we're in a human services part of AWS. And we are usually called on to the projects where customers are asking for our help to move stuff over. So that help kind of usually means that we come in and we're going, okay, what do you want to move over? And we're going, well, we don't know. We have stuff. So that stuff needs to turn into much more. There are 2 things that you need to think about. What do you have, and how do you structure the order of that list? So make a list and prioritize the list. These 2 activities are these 2 outcomes are the major factors for application portfolio assessment. The way how we do it are those 4 steps, and I'll quickly guide you through them, particularly through the first 2. The first one is how we go down the path of finding what it is. And here is our actually pattern or lesson learned now through at least 9, 10 ultra-large enterprises. CMDBs lie. So if you think that you have anything of good, meaningful information in your configuration management database, good luck. We didn't find much of the use over there, so although we always graciously accept all of the CMDB lists that are given to us, don't trust that much anything of that would be true. There are a couple of reasons for that, besides the fact that usually the CMDB push happened so many years ago and then nobody really cares. And actually agents that would need to update and populate CMDBs are not really taken care of. But the other part is that most of the modern enterprises already have a highly dynamic virtualized infrastructure, and CMDBs are simply too slow to catch up. CMDB is a snapshot in time, but that snapshot in time can't be done once a week. When I talk to large enterprises and they're going, well, it is quite a recent report. It's like 2 weeks old. I'm going, do you know how much of I can spin up, run and spin down on Amazon within 2 weeks? So that's why CMDBs will never show you much of the actual real results in there. So we rather go on our own. Ideally, we want to actually do the scanning and automation, and you can see a couple of automation tools that I listed on the bottom right of the slide. That works in less than 30% of environments. Not that the tools don't work. We are not allowed to run them. Usually the security team that actually has a whole bunch of tools on their own, and they're allowed to run them all and snoop and sniff and do everything on your own environment. They will not allow to run either Cloudscape or Cloud Mapper or anything like that, because it's not verified and God knows what the tool is doing and so on and so on. It would be nice, and if it is possible, to run any of the automation tools, it's fantastic. When it's not possible, we go back down to the Excel and pen and paper and interviewing and trying to find what on earth do you know in your organization. And it takes time. So although you might think that application portfolio assessment, finding what's there is quick and easy, you will realize that actually put a lot of buffer on this. Our experience is larger the enterprise, more and more of hidden black pockets and unknown dark application world exists there, and actually helps us, helps you, helps everybody to come clean down with a list with all of the information needed. And you see what information we collect. I will not go down the complete list that you see on the top right side of the slide. But the whole idea is that we need to, particularly the things that are really hard to find out, are dependencies. Very few systems are running isolated in silo. We always need to find what does it depend to. Of course, it will always depend, it should always depend on some authentication engine. Probably depends on the database. So you will see that very frequently migrations where we saw the efforts of, we always do that. Application modernization is around for 20 years. And one of the waves, if enterprise took it too seriously, and part of the modernization was, do you remember database consolidation efforts? When you consolidate everything into one database store, it's really hard to actually plan, and you have 50 systems depending on one database. Yeah, that one database we need to very carefully plan what to do with that one database. Do we shard it again? Do we yes, I know that you moved all of the 20 databases into one. Now maybe we need to start plucking out individual tables and individual data, or that information is super important. What depends on what? So the dependency chain, and not just all the attributes, which operating system and that, but dependency of the systems becomes super important when it comes to application discovery process. Let's assume we have all of that now. Then it comes to the critical question, where do we start? Let's say you get a list of 1,000 apps. That process that you saw before, it's easy when you are under 20, maybe under 50. When you go way over 200, 300, 500, the largest client that we work with has over 4,000 apps in their portfolio. And then you look into this, and it is just a lot for a human brain to comprehend. So our approach, our model, how do we actually segment them out? The easiest way to explain to executives, we try to look across 2 dimensions. How complex the app is and how business critical the app is. And we start with a low complexity, low business criticality. Are you asking why? Yes, you are asking why. Because you don't really don't have a routine yet. You need to have a set of apps to learn on first. You learn how you do specifically a JBoss on low complexity and low business criticality. And then you move on to another set of platform, another chain of dependency, and maybe you have something on Microsoft Stack and so on. But definitely your team that you put together for Application Migration Factory, and we'll show you in a couple of slides how that works. You start with a low complexity, low business criticality. Then you go to high complexity, low business criticality, and then you slowly move to the upper 2 quadrants. Except, if you follow just that rule that I told you, the real value for your management will not be really seen, because it will look like you are churning through unimportant, almost like a 3rd tier, irrelevant apps. So kind of why are we doing that? Are we just cleaning, mopping the floor? Why are we not going for our crown jewels? So you need to find strategic placements for the right high visible apps that you kind of slot and dot in that otherwise learning curve. And it's not a science, it's much more of an art that you find which are the apps that will come high on a visibility chart, but will still have a low probability of failure when you move them around. The other part that you need to understand is that as you will create the migration factory, and actually I'll already tell you now what I have on a future slide, you need to treat it as a production line, which means whenever something is stuck on a production line, you don't stop the rest of the production line. You chuck it out and you put it to another queue. It's like a too hard queue. So you need to create that segmentation prioritization just like you want to create a high velocity of a migration end to end. So if one app looked simple, but it's not, don't stop everything else and go, we need to grind this one through. It's okay to incur technical debt, and we'll talk about that later. Think about that, how many apps per week are coming through. If one of them is stuck, push it back to the queue, and it will go into a harder bucket. Okay? So a couple more things here. Probably the sizing is also very important, particularly from perspective of cost saving. You want to move things first that will give you a very high level of value realization, which means that if something is really either huge and that's why very expensive, or is license-wise huge and that's why very expensive, these are the things that actually matter highly. Hopefully you have something that is really big but very low on business criticality and not very complex. First candidates would be high availability, disaster recovery, business continuity, all of those systems that actually you need to have highly redundant, you need to have all the snapshots, you need to have all of those backups done. These are amazing first candidates for application migration in order to warm up your team, warm up the engine, and actually start the migration factory to churn through. And then, when we looked into how do we do that, we started to build our application disposition model, which on surface is very clean and ideal, and probably if you go through any other vendor, and probably most of the analysts are talking about all of those different approaches from rehosting to much, much more complex at the bottom, a replatforming, maybe even complete redesign. There are a couple of let's say problems with this clean, happy, easy picture. Those boxes, they don't actually show you the true journeys, and every one of those is a very dramatically different journey. Just looking into the redesigning or refactoring, that means that actually you need to have your source control, so that's not even applicable for COTS, consumer off-the-shelf applications, but it requires hard engineering skills. And then lots of choices will be made when you are doing refactoring. Do you bet that your target cloud provider, which would be us, I hope, will be around for a longer time? which means that you need to start looking into how exactly am I going to move that stuff from design perspective. Am I willing to go into a lock-in with a cloud vendor, or do I want to have a portability high in mind? High portability means using lowest common denominator. And suddenly you get into huge friction fights between architects. One side will go, we want to use the best deeply embedded cloud features, and look what AWS is using and nobody else has it. And then you'll have an enterprise architect that will say, yes, and we go there and we can never escape. So there is a huge amount of battling going on once you start going, even the decisioning. Am I lift and shifting? Or am I dropping this app and actually buying the SaaS alternative, which we call drop and shop? So there's lots of those alternatives. And once we start looking into it, this is the actual story. There are no clean, easy migration patterns through the dispositions that you saw on the previous slides. It actually is hard. It's not easy to make those structured governance cycles across different journeys. Let me start on this slide first talking about the journey on top. When I said that you start with simple and non-business critical, you need to follow the path on top, which is dotted line. Why is it dotted line? Because this is not the path that you want to do again and again and again. The manual migration is there to teach your team to bring cohesion, to have an operation person meeting the developer for the first time. And they go, oh, okay, so you do coding in our company. Oh, you do operations in our company. And this is the first step towards the DevOps practices. You need to start doing them manually. You need to bring people together. And that's why that journey on top is there to help people meet people. We did that very successfully with very large enterprises that actually we launched large sprints to actually bring people together and almost have a, the migration get-togethers. You could call them migration parties if you want to, just in order that teams together learn, let's move 10 apps on JBoss over, and that's how we will learn how to do remaining 2,000. And I'm not kidding with those numbers. Some customers are on that scale. Now, if you're looking at the beginning where it says determine the migration path, some of the hard choices that has to be done are those two that are going backwards at the bottom. Not everything will move, and you have to accept it. Not everything can be or will be migrated. And cloud and AWS is not always the only or the right target. So there are options either. Let's talk about retiring and decommissioning. It's very interesting how frequently we find so much of a dead wood in the enterprise where they're going, well, yeah, I remember that somebody used this app and we don't dare to turn it off or anything like that. There is a very specific set of activities that you need to have internally to decide, does it stay at all? Is it worth even investing all of the time and effort to move it, or do you just retire and decommission? We have customers that actually decided that they need to run certain set of systems for compliance reasons, because they did some engineering parts 35 years ago that are now running in some, I don't know, airplane in Kazakhstan, and whenever they ask for the service repair, they need to have those systems still available. AWS, it's almost like a garbage collection for those old brittle systems that can go. It's a museum for them, right? So you need to find what are the right patterns for you. But the four most important and most common you see coming from the migration path. One is rehosting. Then you you don't really touch much above the hypervisor. You grab all of that with a forklift or manually and try to drop on another virtualizer in AWS. And that lift and shifting or rehosting is actually one of the things that can be done fastest, is most automated, and provides least amount of value. Paul, with his brutal language, doesn't call it lift and shift. He drops the F in the second word, because if you have a mess on a source and you forklift it over, you still have a mess on the target location. So if high volume and high speed is your priority, and you are happy to have a huge amount of technical debt, That path of rehosting, lift and shifting is okay. It's not ideal, but it's okay. You will see that it is pushed quite heavily by the industry simply because you can automate it so much, and kind of on surface it shows very big value. But you always need to look into what do you actually get on a target. Is this what you really wanted? Because you got exactly the same what you had on a source, with every same human manual mistake that was done on a source. Our automation automates what you have in there, and you have a human mistakes. We just do them faster now on the other side, right? That's the only difference that we do with our cloud automation in that journey. Replatforming is a much better, because we are trying to reshape a lot of what you have, but we need to understand, you need to start to understand what can be reshaped. Can you reshape a database? Can you move off, for example, a very common pattern would be remove Oracle, replace with Postgres. Postgres, SQL, and Oracle have a very high level of API compatibility. You spin off a little project, you test if your whatever business application that used to run on Oracle now can run on Postgres, and deploy with Postgres on RDS and put on top of it that application. That would be a very, very common replatforming. You change the database platform underneath it. Also changing, going, for example, from BSD Unix into Linux environment and kind of go down to the much more frequent patching, security fixes and all of that. Or maybe looking in replatforming, going from Solaris or AIX into a Linux environment. You don't need to go to cloud. You can actually do that straight in-house if you want to, but those replatforming projects are very, very common that are actually bringing higher value than just lift and shifting. Repurchasing is traumatic, because repurchasing means that you need to start doing hard choices. How much is good enough? If you have your fantastic custom CRM in-house that was made in-house and probably developers don't even exist anymore, and then you're looking on the other side, you're going, am I going with a Salesforce? Am I going with a which CRM solution will I take? Sugar or whatever it is. This is literally the drop and shopping activity. I will drop the old stuff and I buy something that is new. And what is that new? Is it 60% functionality good enough? Is it 80% good enough? Where is that good enough bar that your business people are okay that maybe UX looks different, maybe some functions are different? Finding the match, you will never have a 100% match, right? So when do you decide that this disposition is proper? And then you have a refactoring, which means let's grab a code and start changing it massively. You see that everything of that converges together into that same point of testing and going to transition into production. Here is where I usually start telling, particularly leadership in large IT, how similar that IT as a production line is to a car manufacturing. If you remember car plants 50 years ago, you saw photos probably, you have all of those blue-collar workers. One is welding, the other one is painting, the third one is putting glass in, and kind of hundreds of hands that make a car that comes out at the various level of quality, and somebody does the quality inspection, another human does quality inspection and rolls out. If you look at the car factory now, there are no humans. There is a robot that is doing welding, and there's another robot that is doing painting, and another robot that is doing everything. There are no humans. Same is happening to IT. There are no humans on production line anymore. Everything is automated. Where usually the discussion starts, so where are humans now? Where are my IT people if everything is automated? Just like in a car industry, we turned them, everyone that we could, we turned into cybernetic engineers. Here, we need to turn IT people from being people that are allowed to touch production into people that are allowed to code production. And that's the other aspect of the DevOps that we like to start pushing into it. Everything that you have in your app, and you will see it later, I will describe it in a detail, everything can be and should be and will be codified. So from that perspective, oh, this is the slide. That perspective, Paul. I am saying that phrase way too much. Our problem is, let me go back here. Our problem is that you are thinking in IT industry, as an IT department in enterprises, you are thinking about IT capabilities as your base units that you want to move. What we are providing you is the stuff at the bottom, which is the cloud service. So we created a bunch of migration steps. You can think about them in the architectural space. You will hear a little bit more about the template layer, definitely later by our Expedia colleagues. But we want to break every IT capability that you have, let's say the predictive analytics or collaborative workflow solutions or anything that you have on a capability map. We break it apart into workloads, and then every workload into stacks, every stack into proper templates, and then templates are instantiating our cloud services. That's actually the only proper decomposition that you can do to map any highly complex enterprise app into base primitive cloud services. Now, when it comes to refactoring, we created a canvas, and I briefly touched on it yesterday in my cloud adoption framework talk. We use the canvas to actually help an architect. They grab the application on a logical decomposition diagram, and they're going, okay, how do I map that into the cloud? So we do have that mapping canvas that you can look into it and are going, well, for example, how do I do a simple website? Website needs a browser over HTTP on top, and at the bottom, I'm using some Java-based application server, which is most probably Tomcat in this case, and then it moves further down the stack into, obviously, we are using, you can see on the left side at the bottom, some static objects would be in the object store, distributed globally over CDN, but then all the dynamic content, some of that is in my managed relational database, and so on and so on. You want to see the mobile app? Fine, we have a pattern for mobile app. We have a pattern for any app that you want. Actually, you start with a canvas and you start looking into what capabilities you want. And this is the suggested approach for our decompositions. Now, the process of kicking off the factory and going through that whole process of migration, we're following very commonly defined process. On a very high level, starts from a strategy and analysis and goes all the way to operations and improvement. And improvement. The improvement is the crucial one here that I want to emphasize. Without the improvement phase, you cannot sustain technical debt. You need to have an improvement built into your cycle so you can easily put consciously bad decision, either architecturally or engineering-wise, or we are taking a shortcut, or we're taking a tool that is not strategic, and so on and so on. Because in the improvement phase, you will reassess and you will decide, is it worth fixing now or later or whenever? You have to have the improvement phase. So you don't subscribe to that first yield right approach, because you will spend too much time in that second stage here, which is analysis. What do you prefer? A lot of paper analysis or quick turnaround and readdressing now and then? And again, there's no one right answer. We are just seeing the common patterns in the industry. There's a whole bunch of partners that we are using and partner tools that we are using. I'll not drill into any one of them specifically. This is just very much what we use and what we see in the industry throughout the life cycle of the migration. They're all great. They're all our partners. Actually, one that I didn't put here on the slide, but I probably should be at the last bottom right corner. In the optimization cycle, we should also talk about our trusted advisor, which is our own analysis tool. How are you using AWS effectively? Are you using right set of instances and so on and so on? If you're not familiar with Trusted Advisor, highly recommend it. Go, look it up, use the Google, and you will see what Trusted Advisor by AWS can do for you. It's a tool, it's not a person. This would be one sample Gantt chart of how we try to compress things. Don't read too much into horizontal tasks that we have here. I just want to show you that actually we are creating the complete journey from strategic initiative all the way to actually kicking the migration, doing everything in there. And we are talking weeks. We are not talking years here, right? We are trying to create that as efficient, as fast as possible. The way how we put teams together, it's kind of a blend of two things. And again, this is coming out from that cloud adoption framework that if you didn't listen about it yesterday, grab my recording and you'll learn a little bit more about the process, people domain, people perspective that we are having that in. Look at that horizontal overlay that I put across those people. This is kind of what we call a two-pizza team. The actual structure is the HR enforced structure, but the people that are doing, for example, they're clearing the backlog on JBoss applications would be that team that includes one security lead, one compute lead, and 4 more people. Why we call it 2-pizza team? We found out that if team has more people than you can feed with 2 pizzas during lunchtime, it's just too much of the interaction and you will kind of slow it down. Well, there are exceptions, because Paul alone is a 2-pizza team, right? And he will do that on his own. But in general, don't be hung up on that lunch metaphor. Teams should be small, nimble, empowered, so they can do really autonomous, rapid, independent decisions. Here, I burnt more than enough of my time, so I want to call over colleagues from Expedia. So Aman and Magesh will tell you how they actually did that, and I personally found their story absolutely fascinating. I hope you will too. Please.
Thanks, Miha. Thank you, Miha. We're excited to be here and tell you our story. I am the leader for Expedia Engineering, and typically I call myself the chief overhead. Magesh is our more senior architect. We call him the chief developer. And we're going to tell you a little bit about how we started to crawl and then walk and then run in the cloud. And we'll give you a little bit of an organizational perspective. We have very little time, so we'll touch on things at a very high level. But really where it starts is that a couple of years ago, we realized we didn't have the expertise. We said, step number 1, this is like we're a travel company. It's a journey. And we have to embark on this journey. We have to get started. So the first piece was sitting down and really building a lot of expertise. I would say in the last 2 years, we've got to the point where we really have capability within our organization that we can do pretty much whatever we want in the cloud space. We then went through a sort of application assessment, not too different from how Miha described it. We picked apps that were non-PCI. We initially picked apps that were content-based because it was easier to get those out there. And like he described, we picked apps that were low risk but decent visibility. We didn't want to have stuff that was small and minor because it just wouldn't have the visibility on them. We also wanted regular results. Every few weeks, we would build something, we would deploy something. Every other month, we were talking with the most senior people in the company that, hey, this app got deployed. Look at what this has done. This is the change, which encouraged more people to sort of jump on board with us. And we initially funded our own experiments. One of the things a lot of enterprises get hung up on is who's going to fund this. And what we did within the technology team is we said, here's a bunch of spend we have. That's our own spend. We're going to repurpose a bunch of it and be able to show value so that the company wants to invest behind our success. And we're not going back and asking for a large amount of money initially. What that led to was us establishing trust with the senior leadership. And that's gone a long way for us. And I think from this slide, I'm going to hand it to Magesh to talk about some of the stuff we got ready for this journey. Any travel you do, you grab a lot of stuff to take with you, and Magesh is going to walk you through it.
Sure. Thanks, man. So nothing scary like that, right? Not a lot of baggage that we had to pack. We packed a few tools for letting our developers pick them up and walk free. But what I mean by that is the application that we hosted in Expedia, or that runs our core site, it's a monolith. We have a large presentation here. It's a single Java app, gets built, shipped every week. 200 to 300 developers write code, and works like a well-oiled machine, right? We don't have to worry about it. It just ships every week, and we ship content multiple times a day, multiple times an hour. Just keep pushing views, JavaScripts, images, whatever we want to create a page, we just push it out every hour. It works fine. It works well even today, and a lot of developers are happy with this. They're comfortable because they got used to it. There are lots of tools that support it. As we started our journey into the cloud, we wanted to achieve something more than just lifting and shifting it, because we can probably have done it with some amount of work, take the application, retool it, make sure it is stateless, make sure it can auto-scale, and put that in an Amazon environment and run it and say it's done, right? We are running our core application in Amazon. It runs in multiple regions. We are happy. But that's not what we are about. We were trying to help our developers go free. We don't want the 300 developers to sit and write code together, work as a team. We want teams to be independent, 2 pizza teams probably, to just pick up their bags, own their own applications, run their applications on their own and be independent, right? That's what we were after. So we made a decision to write new tools that will support developers do that, right? And there is no specific order here. To the tools, we developed them in a very iterative fashion, right? Day one, within the first 8 weeks, we had an app running, so none of these tools were completely done, right? It's manual. I will go over the tools. And there were last 2 tools we did much later in the cycle, and I will go over them. So the first thing, Prime. That's a cloud-based platform. No relationship to Optimus Prime. It's just named our app as Prime. It's a Java-based platform. Easy decision. We know how to run JVM applications, so we decided that the new application is going to be in JVM, and also we had lots of libraries that supported an Expedia application, right? How do we identify our customer? How do we run A/B experiments? All these things are Java libraries, so we thought we would just take them along, right? That was not the easy task. The libraries had lots of ideas when they were written 7, 8 years back. They assumed the server is going to be there. They assumed the flat files will be there that I can take 30 minutes to ship to the log server. They had lots of assumptions. They assumed that the application will always build using Spring. Why would people not write using Spring, right? So we had to shed a lot of them and rewrite a lot of these libraries. And again, we iterated pretty heavily. We used open source as much as we can. We don't want to reinvent the spaces where Netflix and a lot of Apache libraries have done. So we just pretty much used libraries there to kickstart ourselves, took the platform libraries that we had and restarted writing them as we needed. So first 6, 8 weeks, we got our first application running, right? It's an iterative process. The platform itself has gone 2 or 3 generations since we started 2 years back and to where we are today. And we use a lot of Amazon SaaS, so it's more like a drop and shop. So we sometimes, we of course abstract. We're not like completely married to say that, yeah, we put a wrapper around it and say we can use Memcached on our own or use Elastic Cache Memcached or abstract Redis, right? There is some amount of abstraction to keep us, but then you don't spend a lot of time reinventing what we can use right off the bat. And
go to deploy.
Deployer. So once the application is done, we wanted to deploy. We started a very simple tool. We took Jenkins, we took Chef, and we said we got a deployer running, right? It can build an image using a Chef cookbook, deploy it, and we started there. But this tool has gone multiple cycles, and what we have today is something that does everything for us. It creates new stacks for us. It releases our new stack to turn our traffic to the new stack. And it destroys stacks that should not exist there. So it basically becomes it performs all the cosmic functions for us in the universe of creating, deleting, preserving in our environment. So the core tools are Jenkins, Chef, and CloudFormation. We create one image as soon as a developer checks in the code. In about 10 minutes after the check in the code, the test environment, the whole stack gets created, a new load balancer, a new web server with the new version, the old one is running. Right? Let's assume the new one is called blue, the old one is green. We use Route 53 weighted load balancing, so 100% traffic still goes to the green one. We say that now it's time to release, the weight gets shifted. So the old one gets 0, the new one gets 100, the traffic starts flowing in, and then we delete the old one. In test environment, everything is wired up. So from the time you commit to our application running in 15 minutes in test environment, that's done. From there, it's 5 minutes to integration and 5 minutes to production, because you don't recreate the images. We use the same image and move the image around to production. So in production, we don't release automatically. So we separate the functions of deploy and release. So there is a deploy where the stack gets constantly deployed and deployed and deployed in new versions. When the team is ready to release traffic to the new version, they push a button to move the traffic over to the new one. Traffic moving is typically 60 seconds TTL on Route 53, and that's typically what we do today. So our stacks to production, from the time you check in to code going all the way. There are some teams, they do end-to-end automation. There's no manual push anywhere until it goes to prod in about 45 minutes from the time the code has been checked in.
We go next?
Yes, next. So the next one, so now the app is running. We wanted to monitor it. Of course, we had lots of tools in our monitoring infrastructure in our data center. We rebuilt them in AWS primarily to support multiple regions and bring them all into a single pane. So we started with CollectD. We run CollectD on all our instances. Every instance that starts up runs a CollectD agent. The CollectD agents ship data to Graphite about the health of the server. Now, CollectD has lots of plugins. If you have standard Apache, Tomcat, Memcached, Kestrel, name it, they have lots of plugins to bring the health. The application metrics, right, it's something that we write. We use Netflix Servo to ship. So we wrap Netflix Servo as a Java agent, so we don't do a whole lot of work. We deploy an app, deploy the Java agent, it ships the logs, metrics to Graphite. We built our UI tool with D3.js, Graphene, and Grafana to pull the graphs together, and we customize Siren so it can be used for alerting. So the actual monitoring and alerting platform sits in our data center, connects to all the regions, pulls the data, and we pull data from CloudWatch, from our load balancers, and pull the metrics together. That's how our monitoring platform is. The next one, this is the most important tool that we built, the most important tool. When you move an application from a monolith into a bunch of microservices, like what Werner was saying yesterday, he said that's where the world is going. Guild moved their 7 monoliths into 300 microservices. Or that's typically where the applications are going. When you're running in cloud, a monolith application is not going to function. You're looking at microservices and microsites. But once you start running microservices and microsites, you have to bring them all together to make Expedia.com, right? It's 50 applications, 100 applications. Each one might be running 2 pages of our site. We have to bring them all together to make Expedia.com. So that's where the thing started to say, OK, I launched our first application. The first application was a content-rich application, as Aman mentioned, as Miha mentioned. It's content-rich, high visibility, but low impact, right? It doesn't take too much. The probability of failure is less if I'm just serving content, right? So I'm serving hotel reviews. We have all the reviews, we just have to serve, right? That's where we started learning. We put that in a subdomain, xyz.expedia.com, no issues at all, because it's behind the scenes. As we put our first shopping app, we wanted our brand. It should be expedia.com/xyz, not xyz.expedia.com, no more subdomain. So we said that, OK, we will just make one easy change. Every traffic goes through Akamai. Let's put a rule in Akamai so that whenever the request comes for ABC, send it to the new site running in Amazon based on GTM. Worked well for the first generation. As more apps came in, last summer we realized that as one of our critical apps started moving in, we realized that we wanted to control the change. We wanted the change to propagate faster, not wait for the 45 minutes for Akamai to propagate. We wanted the ability to fail over from one region to another region, so we built our own proxy. So after we build this, we see Netflix Zool, it's pretty close. So where traffic comes in, Hopscotch makes a decision, where should I route the traffic? Can I serve this traffic in the local region? Is an app registered with it? Yes. What percentage of traffic should I send it? So the developers get a chance to dial the traffic in from 10%, 20% to 100% until you are comfortable running your application to move your data center. So if you see that if we have a monolith that's sitting in Chandler in our data center, and you take a part of the application, call it as one of our shopping pages, and your team rewrote it, registered the shopping page with the Hopscotch server in Singapore, and it says when a request comes to Singapore, which is 1/5 of our requests, in that one, put 10% into the new app. Right? Hopscotch sends only 10%. Now you're comfortable. You see that the service is running. Increase the dial to 100% in Singapore. Everything is running OK. Then roll it out to Europe and US. Right? So it gives a nice way for us to move our traffic out of our application in data center into AWS without any impact. To customer, no SEO impacts. Everything remains the same. URL remains the same. Everybody's happy. The last two. This is the last one. This is a story for Primer. This is our factory. So we built our applications. Everything was there. Toolings were there. It's 4 command lines, or 5 command lines. Everything has been set up to run an application. But the adoption, after the first 18 months, we still see was slow, right? people are not, they are still comfortable, happy doing what the 1-week releases. Why should I move? Even though it's all easy in Amazon and it's working in multiple regions, the adoption was slow. A couple of senior leaders pushed me and Aman to do a tool that will just do end-to-end automation. And what we did was we started with Primer as one app where you go as a developer and say, I have an idea. I want to launch an app. I want to have a page. You click a button. It creates a Git repository with a sample code. That's a template from a templated sample code that runs a Hello World Expedia application. By that, I mean all platform layers wired in. There is a sample app running. And the chef cookbooks get done. CloudFormation template gets done. And the app gets deployed. And after you push the button, 10 minutes later, you get a URL saying, this is where your app is running. And here is where a source code, you can start writing your code. So at that point, the developer just starts focusing on what the code is, and the pipeline just takes to test environment, from there to integration and production. After we launched with the Spring as the first one, because that was a widely used framework, we saw the team started putting their own templates. There's a Spring Boot showed up, there's a Drop Wizard showed up. We have now a template for Apache Storm. We have a template for Ticker, which is our trending application. It can trend anything from server metrics to price. And the last one is that last week, even Scalatra showed up as a template. So it gives us a nice way to, the templates give us a nice way between, or a nice balance between standardization and innovation so that there is a working sample for you to start with. And if that sample doesn't have an example on how we will cache, people go and add it into the template so that the next time somebody launches, they have an example on how to do caching in Amazon. So
why
that's
don't we
Primer.
move on? We're a little short in time, so if you're interested in more of the organizational side or how the journey sort of continues, you can come talk to me right after this. The thing I would tell you is don't hesitate to iterate and don't hesitate to destroy. You're going to go try things. If it doesn't work out, that's fine. Just kill it. Start again. There's no big deal. The cost is not too much for you to reinvent and do it again. And the last thing I would say is just enjoy the journey. You're all here at AWS reinvent. I'm sure you're seeing all the new technologies. The way we think about it is the destinations we send our customers to, they get to the destination and they enjoy. In the cloud space, the destination keeps moving. So you're always catching up. So get used to the idea that you're going to enjoy the journey and you're going to be catching up all the time. So I'll ask Miha to come back up and close this out.
Excellent. Thanks so much. Thank you.